This is lesson 2 of chapter 6, and the title of this lesson, Multiplication and Division Equations. We go back to the essential question, what does it mean to say two quantities are equal? And the reason for this essential question is because when we are dealing with an equation, we're talking about two quantities, okay? And for us to be able to determine if two quantities are equal, we need to know the skills in how to solve linear equations, okay? So let's go here, what you learn. If we scan our book, okay, we can find the definition of what a coefficient is and the formula. So we've defined a coefficient before in our previous lessons, okay? And we know that the coefficient is the numerical factor of a multiplication expression. Okay, we'll talk about that a little bit. And the formula is an equation that shows the relationship among certain quantities. So again, when the word formula comes in, okay, it is an equation, and that basically goes back to our essential question, or knowing how to see if two quantities are equal or not. So the vocabulary that we'll be learning in this lesson, coefficient, we know that, we just defined that. The division property of equality and the multiplication property of equality. Remember in the last lesson, we talked about the addition and the subtraction properties of equality. I mentioned that all four properties deal with the simple principle of, or that whatever you do to one side of the equation, you do to the other side of the equation. Okay, so we'll go there in a little bit. Right now, let's take a look at how coefficient comes to play in this lesson. So the expression 3x means 3 times the value of x. Okay. The numerical factor of the multiplication expression, like 3x, is called the coefficient. So in 3x, our coefficient is 3. Okay. So the figure below illustrates the multiplication equation 3x equals 6. So you have 3 x's here. The equal sign is there, and this is equal to 6. Okay. So if we are going to solve or find the value of x, okay, so in this equation, we want to find the value of x. So we want to find the value of 1x, okay, and if we do that, and if we divide our x's and our 6 by 2, or sorry, by 3, so we divide the left side of our equation by 6 and the right side of our equation by 6, and we group them by 3's. You notice that each x has a value of 2. Okay? So the solution for 3x equals 6 is 2. Okay? So that's using models. And let's see how that works in the following examples. Write an equation that represents each of the models below. Identify the coefficient in your equation, then solve. Okay? So first, the equation here, you have 3 x's and you have 12 units, okay, unit tiles. So the equation here is 3x equals 12. Of course, we know that the coefficient only exists when there is a variable. So this is our variable expression with a coefficient. We know that the coefficient is 3. Okay, and if you look at this carefully, we want to find the value of each x. So if I do this, okay, evenly, I can see that each x is valued at 4. So the solution to this particular equation is 4. Okay, same thing here. Again, you have 2 x's. So that gives us 2x. And you have 8 unit tiles, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that means this is 2x equals negative 8. Okay, we want to find the value of x again, so that means we need to find the value of each x in our equation. So if we divide that evenly, okay, we know that each x has a value of -4. Okay, so we know that there. And we also know that here that the coefficient is equal to 2. Okay, so those are our examples in terms of coefficient and trying to solve the equation using algebra tiles. Okay, uh, the good thing about algebra tiles, you can do that with smaller numbers. Once you get to the bigger numbers, this is the method that we want to use. We want to use the division property of equality and the multiplication property of equality. First, let's take a look at the division property of equality. The division property of equality states, okay, that the two sides of an equation remain equal when you divide each side by the same non-zero number. Again, it's saying non-zero because if you divide the number by 0, the number will be undefined. And that's just uh, basically telling you not to divide a number by 0. It's qualifying what number you need to divide. Okay? So again, just like addition or subtraction, addition and subtraction properties of equality, if I have A equals B, again, C just qualifies the denominator so that it should not be equal to 0. If I have A equals B and I divide A by C and I divide B by C, it will still be equal to A equals B. Okay? So these two will be equal to each other. Okay? Whatever you divide to one side, you need to divide to the other side as well. Let's take a look at how the division property of equality works in solving equations. In the first example, we have 20 equals 4x, and we want to check our solution, see if it's right or not. So first things first, write down your equation. 20 equals 4x right there. Oops. And do that thing. There you go. 20 equals 4x. Okay. Now we know that 4x is 4 times x. So using the division property of equality to undo multiplication, we divide. That's why we use the division property of equality. We divide both sides by 4. If we divide both sides by 4, the 4 cancels out because 4 over 4 equals 1. And we know that 20 over 4 is equal to 5. Okay? So after simplifying it, x now is equal to 5. Okay? Let's check it to see if our solution is correct or not. Okay? So first, we substitute the value of x to 4x. This is our original equation. So we know that x is equal to 5. Substitute that to x. This now becomes 20 equals. Is it equal to 4 times 5? We know that they're the same because 4 times 5 equals 20. Okay, so we've checked our solution. The solution is 5. Okay, let's take a look at example number 2. You have negative 8y equals 24. First, again, we copy down the problem. We write the problem down. Negative 8y equals 24. And if you notice, we want to isolate y. Therefore, we need to undo negative 8. Okay, again, we know that negative 8y means negative 8 times y. So to undo multiplication, we need to divide both sides by 8. Again, according to the division property of equality, whatever you do to one side, you do to the other side. We divided negative 8 on the left side. We divide negative 8 on the right side. Okay, again, by doing so, the negative 8 cancels out. So we're only left with y. And we know that 24 over negative 8 will give us negative 3. Okay, let's check the solution, see if it pans out. So again, we have our original equation, negative 8y equals 24. We know that the value of y is negative 3. We substitute negative 3 to y. Therefore, we have next negative 8 times negative 3. Is it equal to 24? We know that a negative times a negative gives us a positive. So this is 24. So therefore, we've checked our solution. The solution is negative 3. Okay? All right, do got it problems A, B, and C. Let's see if you understand examples 1 and 2. Let's take a look at example number 3. Leela sent 574 text messages last week. On average, how many messages did she send each day? Okay, so again, what do we know? That she sent 574 text messages last week. Okay, and it's asking us on average, how many messages did she send each day? So we know that in a week, there are 7 days in a week. So we will use that information. But first, let's see what we don't know. How many messages did she send each day? Okay, so we want to represent that unknown with a variable, and we let m represent the number of messages Leela sent. Remember, that's what we want to find out, and that's our variable. We create our equation. We know that she sent 574 messages, and 7m represents the number of days in a week, and m is the number of messages Leela sent. So if I get my 7 days in a week, multiplied by the number of multiplied by the number of messages that she sent, it should equal 574. Again, using the division property of equality, we need to undo 7 by dividing both sides by 7. So we divide both sides by 7, okay? Using the division property of equality, 574 over 7 is 82, and we know that the 7 cancels out. We're only left with m, so m equals 82. So Leela sent 82 messages on average each day. So every single day for 7 days, her average text messages was around 82 messages. Okay? Okay, do got it problem letter D, and let's see if you understand example number 3. So the multiplication property of equality works very similarly to the division property of equality. Okay, in words, what it's saying is this. Okay, it states that the two sides of an equation remain equal if you multiply each side with the same number. So basically the same definition as the addition and subtraction properties of equality, but the only difference is that instead of add or subtract, you are changing those words to multiply. So whatever you multiply one side of the equation with, you need to multiply with the same number. Okay? Again, goes back to our principle, whatever you do to one side of the equation, you do to the other side of the equation. In symbols, this is what it means. If you have A equals B, then if you multiply A with C and B with C, they'll still remain equal. Okay? So let's see how this works in example number 1. We want to solve A over negative 4 equals negative 9. Again, okay? The multiplication property of equality works with division equations. On the contrast, the division property of equality works with multiplication equations. So this is a division equation because we know that A over negative 4, okay, means A divided by negative 4. So this is a division equation simply because you have division, an equal sign, and another expression on the right side. So we need to undo negative 4. And for us to undo division, we need to use the multiplication property of equality. Okay? So for us to undo negative 4, we multiply both sides by, again, write the equation, multiply both sides by negative 4. because if I multiply both sides by -4, the -4 cancels out. So I am only left with A. And we know that -9 times -4 will give you a positive 36. So A equals 36. Okay, do the same process and do got it problems E, F, and G. Let's see if you understand example number 4. Finally, example number 5 is our word problem. Okay, the distance D, Tina travels in her car while driving 60 miles per hour for 3 hours is given by the equation D over 3 equals 60. Okay, how far did she travel? So we know that D represents distance, and that's the reason why it's asking how far did she travel. That means we need to solve for D. Again, this is a division problem because D over 3 means D divided by 3. So first and foremost, let us write the equation down. D over 3 equals 60. So for us to undo 3, okay, we need to multiply both sides by 3 using the multiplication property of equality. Multiplying both sides by 3 cancels out the 3, okay? And we're simply left with D equals 180 right there, okay? So Tina traveled 180 miles, okay? There's one last problem here for example number 5. Do that. And we are done with our lesson. Thank you for watching.